might have seen this trend on TikTok, where you take a 2D still picture of yourself and then turn it into a 3D moving image. It's cool to see, that's for sure. But how does that happen? Well, the answer to that is convolution. Convolution, in simple terms, is a method of blending two functions to form a third one. It's defined as the integral of the product of two functions after one is reversed and shifted. In many cases, the static function is called the signal and the reversed function is called the kernel. Let's take a look at a few examples to visualize this. Let's take the function g, which we will consider our signal. To simplify our first example, g only has one non-zero point. Our next function is our kernel, which we'll call f. F is reversed and then moved along the number line. To get our third function, each overlapping point is multiplied individually, and the sum of all the products is a resulting function. Let's look at this from a slightly different perspective. Both f and g in this scenario are exactly the same. When f overlaps with g, the area under both graphs at any point in time is the value of the resulting third function h at the same point in time. As the overlap between the graphs increases, the third graph increases, and as they decrease, the third graph decreases. Now let us look at what convolution looks like in real life. Imagine you have a leaking faucet. For every unit of time t, droplets of water fall into a puddle at the bottom of the faucet. From this scenario, we can make two functions, d of t, the number of droplets falling for every time t, and r of t, the amount of ripples made by the droplets. Let's say that at time t equals 0, one droplet falls. Each droplet creates the same amount of ripples, so we can look at it as d of 0 times r of 0. Next, let's say that at time t equals 1, two droplets fall. Then d of 1 equals 2. Since it's at the start of minute 1, we can still say that the ripples created by a single droplet is r of 0, since the droplets have just fallen, like at minute 0. Now remember that we still have the remaining ripples from our first droplet, however it's dissipated over 1 unit of t. Therefore, we would have d of 0 times r of 1. To combine the amount of ripples, we would add the two values to get d of 0 times r of 1 plus d of 1 times r of 0. At time t equals 2, we can say that 3 droplets fall. Following our previous pattern, our final equation would be d of 0 times r of 2 plus d of 1 times r of 1 plus d of 2 times r of 0. The pattern would continue as time goes on. There are many more applications of convolution, and in many dimensions. Signal processing in 1D, computer vision in 2D, 3D modeling, like in our TikTok video in 3D convolution, and spatiotemporal computer vision in 4D, which is still being explored. Convolution forms the base of so many common processes, from editing an Instagram post to me making this video, and the applications are still growing. I hope convolution isn't as convoluted for you to understand. Thanks for watching.